Hello and welcome. This is Matt with Certain Things. This is a long overdue video about this cartoon shader. It's been about a month or two since I've been playing with these effects, but in the meantime I've been learning quite a lot. I've been asking and being asked a lot of questions about troubleshooting and corrections, and I've stumbled across a couple improvements I've made that I'd like to show you. So I figured I would put together one little video here to kind of show you all that and to give you kind of a jumping off point to continue this. Because this, the tutorial I made is just a worse version of 100 of them that are already on YouTube, which show you how to do a post-process effect for outlines and how to do a post-process effect for the Cel Shader. And you don't need to have seen mine to get this, but I wanted to show you, that gets you a demo scene looking cartoony. But once you take that and you try to put it into a real scene and you start adding UI elements and particle effects and translucent objects, things just start breaking down. And it takes a little bit of knowledge about what these effects are doing, and there's a couple tricks and tips and cheats I can show you to actually make this effect work in a real scene or a real game. So this is going to repeat quite a lot, and so I will have some timestamps in the video description so you can skip around to the information you want. But basically I'm going to quickly go over what these two effects are supposed to do and what their current limitations are. I'm going to jump over to a piece of marketplace content, the Stylized rendering demo from Epic, which is free, it's available to you to look at, but it has a very similar version of the outline effect, and it has a lot that it can teach us about, advanced cheats for the Cel Shader and some trickiness with the outlines. So we'll take a look at that, and then I'll come back here and kind of give you recommendations on where to take this effect, as well as some fixes and some jumping off points for when things don't quite work the way you want, and a couple ways to cheat objects that just won't work. The issue we're trying to fix here is caused by the fact that we're doing this in post-process. It would be nice to do this in the standard material rendering pass, but you just don't have enough information to do things like outlines or play with lighting data. So we have to do it in post-process, and the disadvantage of that is that parameters you change or changes you make to the material affect everything. And so, if something's not looking quite right, if your landscapes are not looking right and you make some changes, then you very well might break 100 other things. And so the name of the game here is getting the effects to look pretty good on almost everything. And then finding some ways to cheat when it doesn't look right on certain objects. So without further ado, let me just look at these materials really quick. So the Cel Shader. The Cel Shader's goal is to take the standard lighting information, which I can show you by disabling the post-process volume here. It's kind of soft shadows, ambient occlusion, and all of that, and we posterize or threshold it. We pick some threshold of light intensity at which we say anything below this is in shadow and anything above it is fully lit. And that's to mimic kind of a banded shadowing that you might see in a cartoon style. So the way we do this in the material anyway, like I said, I'm not going to go node for node. If you want to actually recreate these, then you'll just kind of have to sit through the big long one that I wish I could redo. But basically we have post-process input 0, which is the regular scene if we weren't touching it with post-process. And then we compare that with diffuse color, which is a channel that shows us kind of color without light information, if I re-enable. So this is like color without material color and nothing else. There's no specularity, there's no shadows. So by comparing those two, we can get a pretty good approximation, a pretty good mask for light intensity. And that's our goal here. We get a grayscale mask that shows, pretty reasonably how lit all the pixels are. The sky pixels are unlit. There's shadow here. This is mostly lit. It's not perfect, and that's the cause of most of the problems with this effect. The main thing is that this camera, which is quite specular, is going to have its specular information interpreted as light information. And so without some corrections, this is going to break specular and metallic objects and certain aspects of emissive and that sort of thing. So we take this mask and we try to clean it up a little bit. Despite our skybox being okay, if you had a non-emissive based skybox, then this could cause problems. So we do things like cull away the skybox in our mask. And then we use the mask as kind of alpha for our regular scene. We say that if the pixels are darker than a certain threshold, in this case we have a parameter for the threshold, we apply the regular scene, with some mixing and a tint, and then the same for the light. We have these parameters here to control that specular information. So if I go here and I connect this back up, you'll notice that the scene is cel shaded, but this camera is still plasticky and specular and reflective. So you can get the sort of hard cel shaded look without any of that by taking these blend amount parameters and changing them to 0. And you notice that removed that specular information, and so if it isn't interpreted by that shadow mask, then it's untouched. This won't interpret things like light color. You'd have to simulate that with these tints. So you could change these to be kind of red in order to simulate light color, that kind of thing. And then obviously you can change the threshold at which we say things are shadowed. This is useful for differently lit environments. You can have different volumes with different parameters here so that you don't have to have the same shadow threshold for caves as you do outdoor environments, that kind of thing. So that's that. The limitations of this cel shader, well, one is that on big objects like landscapes, the shadows tend to show up in splotches, basically. I'm kind of hard-pressed to find any, and then when I do find one way over here, it looks more like a visual bug or a random color change than a shadow. That's a bit of an issue. Also, it doesn't play well with ambient occlusion. Ambient occlusion is kind of the general shadowing of objects caused by them just being near each other. And Unreal kind of does this performance increasing distance blending stuff with ambient occlusion. You notice that when I move close and far away from this wall, well, one, the edge of this shadow is fuzzy and not in a good way. And it changes when I move close and far away. And this can be really pronounced on certain objects, as well as the fact that because these two are separate objects, there's this kind of obnoxious seam in the ambient occlusion. Now the easy way to fix this, and the one I honestly recommend, is just to go into your post-process volume, down to ambient occlusion, and take the intensity down to 0. The Cel Shader doesn't particularly need ambient occlusion because it's a very heavily stylized look anyway. If you really want it, if it really makes things look good, you can make the intensity, something low, and that issue won't bother you too much. Or you can play. There are several settings with that distance blending that you can play with in order to get it looking just right. Alternatively, you might try both for ambient occlusion and for general shadows using the distance field-based shadows. Those are generally going to be more performant at the cost of being a little bit blobbier. But since we're doing this, we're stripping out most of the shadow detail anyway, that might give you some good results. And I'm not sure how the distance field-based ambient occlusion would play with the Cel Shader, but it might be worth looking into. Okay. So that's kind of the limitations of the Cel Shader that we'd like to correct. I mean, the other thing is that just certain objects don't look nice with the standard light rendering. Characters, especially in a cartoony environment, look a little better with maybe softer shadows. Clouds don't light very well with this Cel Shader. You're just going to want to have some more custom objects, and we'll look at how to do that. The outlines. The goal is to create a mask the same way we did with the Cel Shader, but which identifies edges in the scene. And more so than in the Cel Shader, it's going to be dirty. It's going to be picking up edges where we don't want it to pick up edges. So we'll have to do some cleanup, and that's what's going to be responsible for most of the problems. In our case, we're searching for kind of two sorts of edges. One of them is when a pixel and a neighboring pixel are very different in their distance from the camera. Sometimes we search multiple pixels over if we're looking at thicker lines, but if this pixel is much closer than that one, then we can identify an edge here. And that's how we create that mask. The other way is some surfaces, like, say, these edges of the stairs. These pixels are pretty much the same distance from the camera, but they're on surfaces which face very different directions. They have a very different world normal, and that also can create an edge. Those kind of edges I don't believe are available in the forward renderer, or sorry, yeah, correct, the forward renderer, just with the way the graphics buffers work. But I can show you that mask. So this is depth. We're using these to kind of check right, left, up, and down. And then this is the default mask that depth check creates. It's going to have some color in here because of the Cel Shader, but the white is our mask. And you see that for a lot of objects, big defined ones, it does very well. This pixel and this pixel are very different, so it creates this nice hard edge there. Same with a lot of outlines on, you know, these general props in the scene. It is, like I said, a very dirty mask, though. It's picking up edges where we don't want them. The skybox is full of them. We can call that away. If you move far from objects, you get this. Might be difficult to see in the YouTube because of compression, but it's kind of weird dithering on far surfaces where it bugs out, as well as it mistakenly finding a lot of edges on large or far off meshes. It absolutely destroys landscapes, which is something we don't want. So we'll need to clean this up pretty significantly. We do the same with the world normals. I can show you the mask that creates. This will be colored because just the way that it's created, it shows you the direction of that edge, which is information you might want to incorporate if you wanted to have you know, a different effect with this. But this one's much cleaner by default. It doesn't really have the same problems that the depth-based ones do, and so it's a pretty safe one to use. It just finds different sorts of edges. You can see that it's got this whole inside edge very cleanly, which is nice. So we add those together. In our case, we just say if they're overlapping, then we take whichever one was more intense. And this is after our cleanup. We do this kind of multiply power clamp thing to remove low intensity lines. And, you know, it helps a little bit. It's not very noticeable right now, but if I pull up the instance here and I start making changes, then it helps. We now have a pretty reasonable mask for the landscape, at least close by. The distance dithering doesn't happen until much farther away. It's still got some problems, and we're already removing parts that we wanted. Like I wanted outlines around the words Cartoon Shader, and we've already removed those. So if I go any further, then we're going to start losing a lot of the outlines that we wanted to keep. So there's got to be a better way here. And we will take a look at that in a moment. Once again, we do this skybox culling and custom depth stencil checking. This is a good chance to talk about a mistake I made. Not necessarily a mistake, but a method I used that I'm not happy with. I noticed that large, far-off objects, primarily landscapes, were suffering from this issue where the outlines are being applied to like every vertex. Even worse if I use the default. Oh, that's because my instance is overridden with new settings, but by default it absolutely destroys landscapes, and any far-off object really. And so, because landscapes are so special, what I did was, and because the problem exists pretty solely from the depth-based lines, what I did is I added another set here, and another set of parameters. We check right here for a certain channel on that custom depth stencil, and if we're using that, then we use this different set of math, which uses just the normals. It uses different parameters because I wanted thicker lines on landscapes. Excuse me, and that did very well. It fixes the problem, and so this scene looks, you know, pretty reasonable for a prototype anyway. The issue is that this is quite inefficient. You might think that in a material like this, well, if I'm not using that channel, when I get to this if node, right, I don't have to do this math. I can just do this for those pixels, but this is done on the GPU, and it doesn't have the branch prediction that that a regular blueprint might have. Like I've got a blank one here. I might already have a branch in. You can tell I recorded this a couple times. Like in a regular blueprint, when I get to a branch like this, and I have a bunch of complicated logic on the true end and a bunch of complicated logic on the false end, it only evaluates one of these based on that condition. But the materials kind of happens in reverse. It gets to this, and by the time it's gotten here, it's already done all of this math. And so it just picks which which one of those values to use. So these branch nodes add cost, quite a bit of cost. You know, when you're doing a cartoon shader, performance might not be so tightly budgeted, and you might be able to get away with 200 base pass instructions, especially for such an integral post-process effect. But the real problem is that this is not extensible by any means. You know, what if I come across another type of object? Maybe small objects are not getting lines correctly. Maybe I want special parameters for my characters. I certainly can't just keep copy-pasting this and adding new checks here, or things are going to spiral out of control very quickly. So, ideally we want a way to kind of do this calculation-based, right? The things I'm doing are checking if an object is big and far off, and then doing things if that is the case. And so what I could probably do is, instead of copying all this logic, I can apply something when we do this mask cleanup that checks for that. Or I can do something over here that ignores objects at a certain distance, that kind of thing. So doing things with calculation rather than these Boolean checks is going to result in greater efficiency. Okay, so those are the effects and their limitations. Yeah, there we go. Excuse me, let me go ahead and pull up the stylized rendering demo, which you can get from the Learn tab in the Epic Games Launcher. Not the standard marketplace tab, the Learn tab. And I will wait for it to load because I'm too lazy to do any editing. Should be pretty fast here. This came out in about 2014. One of the artists at Epic put it together. It doesn't give you access to a lot of the blueprint functionality, but you can take a look at all the materials. And there's a lot of good stuff here. Just to tease you a little bit, I might be doing a kind of full teardown of this demo because there's a lot to learn about landscape splines and a bunch of cool effects here. So, but we're here for two things. One is these outlines on objects, and the other, believe it or not, is the clouds. But we'll take a look at that when we get there. First, let's look at the post-process for these outlines. At first glance, it looks pretty different from ours, but it's actually quite similar. We're doing the same thing where we take a pixel and we check neighboring ones, you know, offset by some distance, add them together to create a mask. We clean up that mask, and then we do things like check custom depth, cull skybox, and then add the line color in based on the mask. The takeaways that I want from this are this mask cleanup, which is much better than the one we've been using, and this method of generating the offsets for our UVs, for the pixels, screen UVs. Because the issue with ours currently is that it's static. It's not screen resolution dependent. And if you want this to run on a bunch of different devices, you'd like it to work if somebody was on a 480p screen, or mobile device, or 4K monitor, and we can't just always check 2 pixels because 2 pixels is a different kind of percentage of the screen on different resolutions. So we need to kind of adjust by screen size. We do that here, and this is going to be a little hard to follow, but it makes sense, trust me. We take view size as it's a vector of 2 components that is the resolution of the screen, or the view anyway. 1920 by 1080, 960 by 720, that kind of thing. And then we divide each of those components by 320. Why 320? Well, 320 is actually just a relatively convenient number when we're dealing with resolutions. It's kind of a fraction. So say I take 1080p, 1920 divided by 320, gives me a nice round 6. 960, which is the horizontal resolution in 720p, divided by 320, gets me 3. So these are just nice round numbers. This could kind of be anything, but this is just a method of kind of taking our screen size and getting some round numbers from it. It's also convenient because the vertical resolution, like 1080 over 320, is just like a fraction higher. So we can use this seal node to change that. So we divide and we subtract 2. This is kind of arbitrary, and then we do this seal and clamp between 1 and 2. The effect of all of this is that if we're at a resolution lower than 720p, it spits out the number 1. And anything 720p or higher, it spits out the number 2. So this solely exists as a way to modulate the line thickness based on screen size. And we basically just say if we're at 720p or lower, those pixels matter a lot, and so we're gonna have thinner lines because they're a higher percentage of the screen. Then we multiply by, in this case, the number 1. In your instance, you might want this to be a proper scalar parameter because this is actually the line width. So I can change this to 3, and we get thicker lines. And then we multiply by scene texel size, which is an interesting node. It's a little difficult to understand, especially because the official documentation is like a sentence and a half. So if there's one thing I'm wrong about, it is this. So take this with a grain of salt, I guess. But my understanding is that a lot of times in a scene, you want some way to express how high resolution your textures are. And you might say, well, I'm using 1K or 2K or 4K textures, but in reality, you probably want to be using different sized textures for different sized objects. You don't need as much texture resolution for one of these stones as you might for a tree. And so, you know, there's marketplace guidelines if you were to upload content that kind of say what resolution per world units. That's the idea of a texel. It's kind of a shortening of texture and pixel. So texel size, if I'm not mistaken, is going to be like the size of a pixel in texture space in world space. If I go 1 pixel across on this wood texture, how many units in world space did I just travel? How many centimeters did I just travel? So that's what scene texel size is. And if your textures are kind of set up reasonably, which they probably are, and even if they're not, it's just going to have static line thickness, but this is going to modulate line thickness based on both well, realistically, the size of the object. It's going to control the size of the object, as well as at distance it will have thinner lines, but this basically makes the lines the same thickness as the resolution of the texture, which is great. If you're using lower resolution textures, you're probably on a smaller object, which means you probably want smaller lines. And this kind of in one fell swoop solves that problem with landscapes where I wanted different parameters because I wanted thicker lines. Well, landscapes are much, much, much bigger objects, and so when I look at the scene texel size, we're going to get thicker lines anyway. So that's great. So that's basically how we generate our offset. And then we need to R and G, in this case X and Y, offset by that much. So we create another vector that's X offset, comma 0, and then 0, comma Y offset. And then we add that and we subtract it to get the offset to the right, up, left, and down. And then we just compare our scene depth at those offsets to our center and add those together to create a mask. And once again, I can show you what that mask looks like. It's horrible. It has the same problems that we had, where it fills in every vertex of the landscapes. It does this horrible dithering on distant objects. It puts tons of lines on the skybox and the clouds. We need to do some cleanup once again. Excuse me. So our cleanup, first we divide by -300, which might seem like a strange thing to do. You can read in the tooltip here that this is edge angle fall off. Because by default, if I, first of all, connect this back up, and then I change this number to something like, I don't know, -10. Oh, did I not do that? There we go. Then watch this line in the background. When I get to low angles, it starts to stretch out. And that's especially prevalent on objects that kind of stretch out underneath you like a landscape. So dividing by -300, there's a little bit of cleanup there. And then we clamp it. This whole clamp, invert, multiply, clamp, re-invert thing basically serves to chop out the bottom half intensity. So we're basically getting rid of the lower intensity lines with this. And once again, you might consider changing these to scalar parameters, this -300 and this 2. It'd be nice to be able to get it into the scene and then tweak those to get it just the way you want. So consider using these as scalars. We mask it into one channel and then we multiply that So those are the two things that I really wanted to see, but there's also a little bit of good stuff like instead of an if node here, which is what we were using to use a sphere mask, and that's just one instance. You know, this is not going to optimize very much in this case, but it's just an example of the general principle where if you can, you want to do things with a calculation rather than with this Boolean. Because then we don't have to generate both states at the same time. We only have to do one of them based on what math we did. So the sphere mask is the same as our check to see if that render custom depth checkbox is checked or unchecked. Then we do this distance fall off. One other thing, you see these parameters that are post-process blend weight all over the place. Those are actually really just for preview. If I hit play, it's going to make a loud noise. Warning, headphone users, but it fades in. And that's just that scalar being changed. That does a couple things. One is that it ignores our little custom depth checkbox. And we don't really need it to do that. I'm not using it for this fade in. If you wanted to do something like that, you could, but I don't actually need it. So I'm just going to delete this lerp and add that there. Same with this. It actually, when you have that parameter cranked so that we're in kind of preview mode, it eliminates the distance fall off, which I don't really need to do. So I can delete all of this, get rid of this lerp, and this number is kind of the distance at which we fall off. Note that this one says we fall off close to the camera rather than far away, so that we don't draw those outlines on very close-up objects. You can do the opposite if you want, but we can just use the one, and then this changes the scene color so that if we're kind of in preview mode, it does that sort of papery look. We don't need that either. We can just take the regular post-process input. So just cleaning it up a little bit, and it looks the same. So that's kind of what we can learn from the outline, is this kind of screen resolution dependent way of generating the offsets, and then this kind of better way of doing the masking. Cool stuff. Let's look at the other thing we came here for, which is clouds. These clouds are pretty cool. If I can get up to them, you notice that it does this kind of banding stuff, similarly to how we were doing the Cel Shader, where there's bright and then not bright. In this case, it does three bands, bright, medium, dark, and then it does this vertical one as well, where it's bright, medium, dark. But what this is actually doing is it's kind of projecting this vertical gradient, right? This banded vertical gradient of 3, 1, 2, 3, over the whole thing. And then on top of that, from whatever direction the sun is, it's then projecting this highlight, this banded highlight of 1, 2, 3. So, and that's dynamic. If I rotate this, that highlight stays in the same direction. And so you can see how, you know, for clouds especially, but for anything that isn't just working correctly with your Cel Shader, you could do something similar. And this relies on a something I talked about in my little video about making grass move called a material parameter collection, which is, as the name sounds, just a collection of material parameters. Hopefully, if you've made it to this point, you know what a material parameter is. It's like we were playing with in this, where in the instance at runtime you can edit it. But a material parameter collection is a collection of those scalars and vectors that, one, any material can have access to. There are several, you know, there's information that you might want a lot of materials to have access to, stuff like light color, ambient light color, or some scalar for light intensity, that kind of stuff. Alternatively, well, there's some other stuff you can pass into material parameter collections, but as well as being accessible by any material, they can also be edited in Blueprint. And so it's a good way of changing values in Blueprint that materials can read from. And because you can pass in vectors, ambient light color and light color, which you normally think of as colors in the case of material, but it's the same as a regular vector, and it seems like a kind of hacky workaround, but it really is intended behavior that you can pass in any kind of vector. You can pass in a world position or a rotation. In this case, it's a direction vector of what direction is the light coming from, which is pretty cool. And I'm not sure in this case if that's updated by the sun blueprint or not, but if, for example, you had dynamic lighting with this kind of day-night system, then you could totally, in your sky sphere blueprint, update that material parameter, and then the highlights on these, or trees or anything else that used a similar method, would update their highlight accordingly. So you can even use this to generate the look of dynamic lighting. Let me take a look at the cloud material. It's a bit complicated and we don't need all of it, but basically we're using light vector, which is what we're passing in, and then we're using the dot product. If you're unfamiliar with vector math, this is basically just going to compare angles with whatever the vertex normal is, and generate a kind of mask so that we can distinguish like how different the vertex normal is from this light vector. And then we use that to create the stepped shading. This is useful for the Cel Shader, this multiply, floor, divide. If you wanted just a two-banded Cel Shader, you would have 2 here instead of 3. But this is a good tip. So what I'd recommend is that you just kind of look through here. Like there's this good bit about we take the static mesh bounding box and use that to generate UVs for this kind of vertical projection, which is pretty cool. But just the idea that you can use these material parameter collections to pass in that information so that you can generate that light. Because this is a simplified version of the lighting engine, you can, in some cases, do a lot of really, really custom stuff to get something looking just the way you want it, basically. Because inevitably there are objects, you know, tree leaves, clouds, particles that need to look like they're being lit from the sun, but just don't work correctly with the default Cel Shader, and this is a good way to change those. The other thing I want to take away from this demo is that you notice the landscape blends at a distance. So we have this kind of high-resolution stuff that blends into this color in the background. That is one node in the materials editor. If I go to the landscape material, it's called distance blend. You can get it by typing distance blend, or by getting a material function and then selecting distance blend in there. But you just specify like the range. So this blends over the course of 20,000 units, and then kind of the offset. So this distance blend happens starting at 12,000 units up to 12 plus 20 is 32,000 units. And then we use that as alpha to blend between this complicated landscape material and just this dark green color. Pretty cool. So that's a good way of... I think the new Legend of Zelda Breath of the Wild might do this. It's been a while since I played it, so I'm not totally sure, but oops, probably shouldn't have saved that. You could, for example, have the Cel Shader apply either on close-up objects and then blend into the regular lighting far away, or the opposite of that. Any kind of effect that you notice works well close-up or far away, but not both. You can use it to kind of blend between working effects at those distances. You could even, for example, have Cel Shader or outlines have different parameters, close up and far away, and then blend between those if you really needed to. So just a good thing to keep in mind. And this is different from the method that was used in the outlines here. The outlines like divide by this number, and this is to use in the mask. So those are just two different methods of doing kind of distance-based fall off. Okay, so let me go back into the other project. And we'll just talk about, one, what I would kind of recommend doing with this new information, and two, some tips and changes, some easy stuff I noticed to fix problems, and then a couple cheats you can do. So for the Cel Shader, I'd recommend pretty much keeping it how it is. You might want to incorporate that distance blend, which you can do really at any point. The Cel Shader is pretty good playing with ambient occlusion and playing with the parameters of the Cel Shader, as well as the knowledge that you can cheat on objects that don't look correct using that material parameter collection and advanced material. Excuse me. The Cel Shader is pretty good. The outline, you can start with this as a base, or you can copy the Stylized rendering demo as a base. But I would recommend using their method of getting these offsets. We're just looking at a hard number of pixels, whereas there's adjusts for screen resolution and object size. So cut out this stuff, oops, and use theirs instead. What I might recommend is starting with theirs, and then basically duplicating everything to do the normal lines. You just change all of these scene depth nodes to world normal. And then do a similar thing that we've got down here. You might even consider, they do that sphere mask to check if custom depth is enabled or not. You could use one branch. I know I said not to, but one branch is not going to be too bad. Oops, not with B, with I. that checks basically what we're doing here, where we check if the stencil is set to a certain value. Then you do or don't use the normal baselines, depending on whether they're working for you or not. The depth ones are kind of the troublemakers anyway, but you just kind of want the freedom to enable and disable those at whatever point you want. You can use their distance blending as well. Their distance blending and use their mask cleanup. You could even throw their mask cleanup right on the end of this. That kind of divide by -300, clamp, invert, multiply, clamp, invert thing. That'll help a lot to get this to work with landscapes correctly. So then you don't need any of this down here. And you probably don't need this either. And it'll have the number of instructions. We're pretty close to it. So it'll have that, it'll look a lot better, and it'll work with a lot more objects. And then you have a bunch of parameters you can play with, and that should do you pretty well. So let me run over pretty quickly some issues you may need to address. One of those is that in both cases, you want these post-process effects, the blendable location. It has to be at least before tone mapping, or the anti-aliasing is going to play with it a little bit, but you may consider having it before translucency. Each of these happens earlier in the rendering pass and therefore is more expensive. So if you don't have translucent objects, or you don't notice any problems with translucent objects, then before tone mapping is going to save you a little bit. But if I take a particle system, this is opaque particles, fully opaque. And you notice that if I back up, then, well, they appear to go right, the outlines go right through them, despite them being opaque. And that shouldn't be happening. So that's something we need to correct. And supposedly, in most cases, setting this to be before translucency should solve that problem. If it does not, there are a couple things you can do. One is to make sure that in whatever translucent material you're drawing, in my case this particle material, check down in translucency and make sure that render after DOF, or render in the separate translucency pass, is checked. And also ensure that in your project settings, these are both on by default, but if you've changed them, it'll break a little bit of this. Under rendering, translucency, separate translucency needs to be checked. We need that separate translucency pass in order for the post-processing to draw underneath this correctly. It basically allows us to do the post-processing and then that separate translucency. So that should solve that. The other thing is that if this is still not working, you can take your translucent material and you can allow or disable the custom depth, and that should enable you to change those render settings over here. If I go to rendering, the custom depth pass settings, you should be able to change those. And finally, if not, if you just can't change those settings or they're not doing anything, then you might consider, as a last resort, making a random blueprint or something, and then making your whatever's translucent, probably your particle system, making it a child of like a static mesh component or something that's just blank. Means that it'll inherit the rendering properties of that static mesh component, and so you should be able to set the properties here and then have them carry through to your particle system. That'll add a little bit of expense, and it's a pretty dumb workaround, but if it works, it works. So that should help you draw particle systems. I've heard complaints of UI elements drawing underneath the post-process. That should also be solved by these methods. Just to play with it, I added a little UI widget, or I guess create widget. It's a little button widget. And then add it to viewport. And, well, in my case, it works fine. This is a translucent button, works fine with opaque things. You know, you could run into some issues as you get more complex and complex UI elements with images and other materials, but making sure that the material's drawn and have the correct settings, as well as the post-process effects having the correct settings, should eliminate this as an issue. As a last resort here, this is pretty dumb as well, but you can create it as a widget component. Which creates it kind of in the world. And you could attach it at a certain offset from the camera. I know it's pretty silly, but if you have to do it, you have to do it, I guess. And that's another method that you could use if you had to. And that should enable you to draw them more easily, especially because you can more easily change the render settings on those components. So UI and particles shouldn't be a problem. Just make sure your blendable location is set to before translucency, and it shouldn't be drawing in front of windows or anything. So that should do pretty well. Once again, with the Cel Shader, making sure ambient occlusion is either disabled, very low, or using the distance field-based stuff might help there. Let me think. Oh, so I showed you how to kind of cheat the Cel Shader, right? If you need an object that just quite isn't really working. Well, there's something you can do for the outlines as well. You can use the kind of custom depth to disable the outlines, and then you can create an object. I'm going to use Blender. You can use whatever 3D program you want. This method they showed in the live stream that I kind of initially got this outline effect from. But it's called inverted holes. And if I make a cube, well, what I can do is I can make a second cube. Let me give this one a material really fast. And then I will add a second cube, but this time scaled up by like 1.02. And I will give it a material except black. And if I go to material view. So what we need to do is go into edit mode here, shading, and invert the normals on this cube, as well as tell Blender to do backface culling. So now it's facing, the outer cube is facing inside out, and we're culling the back faces. And what that means is that we get this outline where we see the outer cube only on the edges here and only on the insides. And you can obviously, by scaling this in whatever way you want, or by creating geometry in whatever way you want, you can kind of generate those outlines where you want them. The trade-off being that you kind of double the geometry. So doing this in your scene, well, is really going to change your kind of try counts and that budgeting. So it's really unfeasible for stuff like landscapes. If you had to, you could do this with parts of your character or even their face or something, but generally, if something is not getting the outlines in the way you want it to, or if you just want a lot of control over the style, you can do it this way as well. It's not going to do those normal-based ones, only depth-based stuff. But that will work just fine in Unreal as well. So that's kind of it. So that's really where we're taking this. This is probably the last video I'm going to do on this. We're not really using this for our current project, so I'm kind of done researching it. But what I want to leave you with is this, basically. Just know that you don't have to use these effects to do a kind of cartoon style. Epic Games makes Fortnite, which has a very cartoony style without either a Cel Shader or outlines. It just does kind of hand-painted textures and cartoony animations and soft shadows, and that's enough. It is easy to feel like, especially if you're like a small team or something, that you have to basically have a low budget for doing like art. That doing something cartoony or stylized will be an easier way, or will have lower workload on the art side. And in a lot of cases, that's not really true. You can do kind of the standard indie sort of low poly look, and that can help and can be a lot easier to pull off. But something hyper stylized requires a lot of artistic knowledge and a lot of engine understanding, in the same way that doing hyperrealism might require engine understanding. So in a lot of cases, you're not actually saving any effort by doing something hyper stylized, which is what this Cel Shader and outline shader kind of is going to create. So and additionally, because these post-process effects are making such kind of drastic changes, you can't just drag these into a scene and expect it to look great, and know that you're probably going to be fighting them the whole time. That's just the nature of this. You really have to have your art pipeline work very closely with this. So you can't just model a character and bring it in, expecting it to look okay. You kind of have to, at all stages, be looking at it, see how it lights, see where the outlines are, and make changes both to the model. You can accomplish the combination of effects you want is going to be playing with your actual static meshes to make them accept these post-process effects very nicely. doing texturing, maybe incorporating some outlines into textures, harsh corners, that kind of thing, and then post-processing being as light as you can kind of make it, because you'll just have to have all of that work very closely together, and you have to design all of your assets to work in an environment like this for the best result anyway. But this is a way to achieve that kind of hyper-stylized cartoon look, and I think in the end, if you're willing to understand it, it comes out quite nicely. So if you have any more questions, leave them in a comment and I'll try to answer them. I'm by no means an expert, so if you have any extra tips, feel free to let me know. And I suppose get subscribed if you want to see more stuff like this. So thank you for watching.